Previously, we've looked at summing together two independent normal random variables, and you would get a new normal random variable. This time we're saying if you have two or more independent normal random variables summed together, the answer there will also be normal. Now we're going to consider what happens when we have sample sizes of n being taken from a normal distribution. So first thing is you'll see the random variable is defined. X is a normal random variable, and we're going to say the mean of that normal random variable is mu and the standard deviation sigma. From this distribution, this is a distribution of a population. What we're going to do is take out samples. And those sample sizes are going to be of size n. For instance, if we wanted to find out what students at Forest Hill College thought about something, and their opinion of all Forest Hill students on this particular topic was normally distributed, so it was a normal distribution, we were trying to find out some features of that by sampling 20 students as an example. So I could take out one group of 20 students and find out their opinion. I could take out another sample of 20 students and find out their opinion. I could take out another sample of 20 students and find out their opinion. They're the sample sizes, and the sample sizes I was using there was 20. So what are we looking at? A sample of size n from the population. The population was all of Forest Hill students. The sample was by taking out a group of Forest Hill students. Can be described by n independent random variables. If you think about that, x1 was the first sample, the first group of 20 students. X2 was the second group of students. X3 would be the third group, and so on, which have identical distributions to X. So the sample mean, so this is the mean of the sample. You add together x1, x2, all the way up to xn, and divide by n. So the sample mean is normally distributed with a mean of mu, which you would expect, and a standard deviation of mu over the square root of n. This is taking into account that we don't have the whole population, but we have part of the population. So a particular value of the mean of x is found by adding together all those values and dividing by n. This value, the mean of x, is an estimate, a point estimate of the population. The expected value of the mean is equal to mu. The variance is equal to sigma squared divided by n, the size of the sample. Lastly, the standard deviation of the mean is equal to sigma divided by the square root of n.